Hello students, hope you are doing well. In this video, we are going to study about center of mass and collisions, and the topic that we are going to study in this is center of mass. Now, what is center of mass? Center of mass is the point where the whole mass of the system seems to be concentrated. Right? Now, why do we have this situation of mass being concentrated coming into picture? Now, if it is a point mass, I have a point mass, I apply a force F, then let's say it is having mass m, I can say A equal to F by m because it's a point mass. Now, if I have a huge mass, I apply a force F, the mass is m. Now, I cannot say every part of the body is following this A equal to F by m. So every part is not following, but one part will always follow this relation A equal to F by m. That part is called center of mass. That means I can consider this whole mass to be concentrated at that particular point. And then I can use this equation. Fine. So when we talk about center of mass, like you can see the picture here, there is a person jumping. Now when a person, if I throw a stone, it's a point mass, we know that it goes in a parabolic path. Now when a person jumps, not every part of the body goes in parabolic path, but the center of mass will definitely go in parabolic path, right? So what is center of mass? Center of mass is the point where the whole mass of the body seems to be concentrated, right? And now, some regular masses, if you have symmetric, for symmetric mass distribution, sphere or circle or triangle, cylinder, for symmetric mass distribution, geometric center is equal to the center of mass. So we have seen that for symmetric mass distribution, geometric center coincides with, let's say, center of mass. Now let's look at center of mass of a two-body system. So if I have two-body system, I want to find what is center of mass. Now how do I find center of mass? To find center of mass, we define something called moment of mass. So a point where moment of mass is 0 is called center of mass. What is moment of mass? It is mass into distance. So about center of mass, the moment of mass will always be 0 because the whole mass is concentrated at the center of mass, so there is no question of the distance coming into picture. Distance becomes 0. So if I take this as RCM, this is R1, I can say this part can be written as R1 minus R and this part can be written as R2 minus R. So what is moment of the system? Total moment of the system is R1 minus R plus M into R2 minus R is equal to 0. So from this I get R equal to M1 R1 plus M2 R2 by M1 plus M2. This is where we have taken R as position vector. Now R can be written as Xi plus Yj plus Zk. So in that case, what I can say, X center of mass would be equal to how much? M1 X1 plus M2 X2 plus M3 X3, so on. If there are n number of masses, by M1 plus M2 plus M3, so on. Similarly, I can find expressions. Similarly, Y center of mass would be M1, Y1, M2, Y2, M3, Y3, so on. Their addition by the total mass. So in this way, we can find center of masses of discrete mass systems. Now let's see, we have three particles. I want to find center of mass of the system. Now I'll say each particle is having mass m. This is m, this is m, this is m. Now the easiest way is finding the coordinates. Now what are coordinates of m? I mean A, coordinates of A are 1, 2. What are coordinates of B? Coordinates of B are 3, 4. What are coordinates of C? Coordinates of C are 4.5, 0. Now let's say all of them are having same masses. So I want to find X center of mass. X center of mass would be equal to M1. M1 I'll say MA. MA is M. X coordinate of A is 1 plus MB, that is n. X coordinate is 3 plus MC, that is n. X coordinate is 4.5 by total mass. Total mass is 3m. So from this, what do we get? 4.5 plus 1, 5.5 plus 3. So 8.5 m by 3m. Mn cancels. So the X center of mass is 8.5 by 3. Similarly, if I want to find Y center of mass is how much? M1 is m, Y1 is 2, plus M2 is again m, mass of B, Y2 is 4, plus M3 is again m, but Y3 is 0. So by total mass 3m. So this becomes 6m by 3m. So that is equal to 2. So the center of mass is 8.5 by 3 comma 2. This is the center of mass. Now the various things, like we have taken this as reference, but center of mass does not depend on the reference. Very important thing, center of mass does not depend on reference frame. You take any reference frame, you'll get the same answer. The value with respect to that reference might be different. So does not depend on reference frame. So this is, so what factors does it depend on? It only depends on mass distribution. It only depends on mass distribution, nothing else. Fine. So this is how we find center of mass of discrete systems. Now how do we find center of mass of continuous systems? I'll write it as continuous system. So how do I find the center of mass of continuous system? So if I have a continuous system whose density is given as rho of x, I want to find center of mass with respect to origin. Let's say I take a small length of this dx at a distance x. I'm taking a small part of this dx at a distance x. Now what will be mass of that part? Dm. Dm would be equal to density of that part rho of x into area of cross section into dx. Now if rho of x is linear mass density, I can say dm equal to rho of x into dx. If rho of x is linear mass density. If it is the mass density, normal density, then I have to consider area. So here we'll assume that rho of x is linear mass density. And let's say rho of x is equal to, I'll say rho x. So rho of x is equal to how much? Rho x. That means density at a distance x is equal to rho times x, where rho is a constant. So if you are getting confused with rho x, I'll write it as ax, where a is a constant. So I want to add all these masses. So if I want to find center of mass, how do I find center of mass? m1, x1, m2, x2, m3, x3, so on. So because it is continuous mass, I'll integrate from where to where x changes from a to b. M1 x1, instead of m1 x1, I'll write x dm by total mass is how much? Integral a to b dm. So this would be center of mass. Now let me find out in this particular case. In this particular case, x center of mass would be equal to integral a to b. Rho of x is how much? I have taken rho of x as ax. Dm is ax dx into x. So that becomes ax square by integral a to b. Only dm is how much? Ax dx. So that will be equal to integral. I'll just find the integration of x square is how much? X cubed by 3 from a to b by integration of x is x square by 2 from a to b. So a cancels. So I'll take it. This can be written as 2 by 3 into x cube. X cube would be b cube minus a cube by b square minus a square. So the center of mass of this particular rod would be 2 by 3 times b cube minus a cube by b square minus a square. Now we have mass situations where they ask you what is the center of mass of a given structure when a part of it is taken out. So how do we solve this situation? Let me take a circular disc of mass m and radius r. Out of this, I cut out a disc of radius r by 2. I want to find what is the center of mass of the system with respect to the center. I'll assume the center of the disc is 0, 0. The center of mass of the disc which has been taken out can be written as r by 2 comma 0, and the remaining part I'll write it as x comma 0. I'll assume mass of this taken part is m1. Now m1 will be equal to how much? Total mass by total area, that is pi r square in case of disc, into pi into r by 2 whole square. So pi r square cancels. I'll be left with m by 4. So what is m1? m1 equal to m by 4. So what will be m2? m2 will be equal to m minus m1, that is equal to 3m by 4. This is 0. Now if I add this small disk with the remaining portion, I'll get the complete disk. And where is the center of mass of the complete disk? At 0. So I can say center of mass of the complete disk equal to m1 x1 plus m2 x2 by total mass. So anyhow it is 0, so I can leave the denominator. So what is m1? m1 is m by 4 into x1 is r by 2 plus m2 is 3m by 4 into x2 is x, that's what we have to find, equal to 0. So m by 4, m by 4, I take it out. So what am I left with? R by 2 equal to minus 3x, or x equal to minus r by 6. Or the distance of the center of mass of the remaining portion would be r by 6 from the center. So this is how we find it for any situation. Here we are taking it as a its disk, it can be a sphere or any other structure. So I can consider the taken out sum of the taken out piece and the remaining piece to be the complete piece that was undivided. Now, how do we find velocity of center of mass? Now, velocity of center of mass is given by m1 v1 plus m2 v2 by m1 plus m2. So I can, I can extend it. I can write as sigma mi vi by sigma mi. So if we have discrete particles moving with velocity v, then this is what is velocity. Similarly, velocity along x, only I take velocity along x-axis, velocity along y, I only take velocity along x-axis, and so on. Now the same thing, acceleration of center of mass would be equal to m1a1 plus m2a2 by m1 plus m2 if I am talking about two particle system, and if it is many particle system, sigma mi ai by sigma mi. So in this way I can find acceleration of the center of mass. Again, if I want to find acceleration along each direction, then I only equate these things. So this is what is about center of mass. I hope you could follow this. What all things we have seen? We have seen what is center of mass, that's the first thing. Then we have seen how to find center of mass for discrete particle system. Then we have seen how to find center of mass of a continuous mass distribution. Then we have seen a few examples where how do we find center of mass of a system when a part is taken out. And then finally we looked into the expressions of velocity of center of mass and acceleration of center of mass. Hope you could follow this. Thank you very much.